So in these problems, what we're going to be doing is we're going to be identifying, is it a perfect square, which would be a, u plus v squared, or u minus v squared, or is it the difference of two squares, or is it neither one? So let's talk about when it would be neither one. So a couple key things. The easy one's difference of two squares. If you see two things being squared, meaning even exponents, these are numbers that are squared, and there's a minus sign. It has to be a minus sign between them because the difference of two squares, not the sum of two squares, it's the difference. So it's easy to identify that one. Where we might have some trouble is right here. So what I do want you to see is a couple things. So right here, notice these are plus signs on the right. Those have to be plus. Same thing here. These are always positive. You shouldn't have those being negative. Where you might have the negative is right here. And notice with the middle term, just to talk about the middle term, the 2. 2 times anything. Think about 2 times anything is an even number. 3 times 2 is 6, right? That's even. 9 times 2 is 18. That's even. 2 times anything is an even number. So this middle one has to be an even number. In particular, it has to be 2 times a times b. It has to be that. So we're going to check that as we go through this. So looking at this one, this is looking a little bit like the perfect square, right? So this one might be a bit tricky. Could we write, let's just say u, so looking at this for u would be x squared, right? Because x squared squared, if you have u squared, x squared squared would be our x to the fourth. And then what about v? So v would be based on this. So if we think about that, v squared, wouldn't that be 5 squared? So v could be 5. All right, so now let's look at this one. This one should be 2 times u times v. I know we're using a and b at the top, but here they're using u and v. So 2 times u times v. Well, 2 times u times v would be 2 times x squared times 5, which would be 10x squared. So this is really similar. It has the 10, but the x should be x squared. Because it's just an x, that means that we can't use any of these patterns. Otherwise, it could be a perfect square, but it's not quite following that because of there. Let's take a look at this example. This will be our last example. I didn't put difference of two squares because that one is pretty easy. Just got to make sure they're both squares or even exponents, and there's a minus sign between them. So this one's a little more complex. So if you see this, u would have to be x plus 7, right? This is x plus 7 squared. So obviously u is going to be x plus 7. Because remember our form, it's going to be u squared plus 2uv plus v squared. So u has to be x plus 7. Because that's what's being squared. Now what is v going to be? So v is going to be, well, v is going to be y. Because right there we see it's y squared. So v is just going to be y. Now if you look at the center, that means that 2uv should be 2 times x plus 7 times y. And yeah, this one checks off. 2 times x plus 7 times y. Even though it's rearranged, multiplication's commutative, it can be rearranged. So this is 2 times y times x plus 7 is the same thing as this. So this one, yeah, checks off. This one's going to be a perfect square.